So today we're going to talk about the trigonometric circle. So it is important that you remember that the trigonometric circle is a circle that has a radius of 1. So what does it mean? It means that if you look on the graph I created here, that means that this is going to be equal to 1. It also means that this here is going to be equal to 1. So I'm going to be able to find the point that is here, which is 1, 0. Or also this one up here, which is 0, 1. And the one here, this is also 1, so that's going to be negative 1, 0. And at the bottom here, this is also 1, so that's going to be 0, negative 1. When we're going to look at angles on this, we're going to always start from the point 1, 0, and we're going to move up like this. This is going to be positive angles, and when we're going to go down like this here is going to be negative angles. We're going to go down. When we have an angle here, this is going to give us a point, and we can also find a right angle triangle here. This is going to be our x coordinate, and this is going to be our y coordinate. So when you look at that, if you think about the opposite, this would be sine of the angle, that would be opposite over hypotenuse. Therefore, y is equal to sine of theta. And if you do the same with cosine of your angle is adjacent, so that's going to be x over 1. Therefore, x is equal to cosine of your angle. So if you go back in your coordinate here, whenever you have an angle in rad, the x coordinate will be the cosine of that angle, and your y coordinate would be sine of that angle. Sometimes they're going to ask you to find tangent. So if you think about tangent of an angle, that is equal to opposite over adjacent. That's y over x. And y, we said that y is sine of theta over cosine of theta. So that's going to give us a definition for tangent also that we have to keep in mind. There's going to be some angles that we'll see that have a special signification. So for example, here, if we look at this angle here, that's 30 degrees. If you remember, when we reviewed, whenever you have an angle with 30 degrees, the opposite side is half of the hypotenuse. So here, because we are in a trigonometric circle, the hypotenuse is 1, so that means that the opposite side is equal to 1/2 of the hypotenuse, so then it's equal to 1/2. And then, if you remember using the Pythagorean rule to figure out the trig circle, you know that x squared plus y squared is equal to 1. So then we have x squared plus 1/2 square is equal to 1. So you should be able to do that on your own. I'm just going to show you the steps. So then you would have this. Remember, when you subtract, you need to put on the same denominator. So this here is over 1, so you would need to put it over 4. So that's going to be 4 over 4 minus 1 over 4. So x squared is equal to 3 over 4. And then you need to find your x, so you square root on both sides. So x is going to be equal to square root of 3 over 2. So you could come back in your triangle here, and you can say that at the point here, at 30 degrees, the coordinate would be square root of 3 over 2, 1/2. And this is at 30 degrees, but 30 degrees, if you remember when we were talking about rad, if you're here, 30 degrees is here, and there are 6 of them that makes pi, so this is the same as pi over 6. So you could write that the point at pi over 6 is equal to this. Another triangle that's going to be interesting is when you have 45 degrees. So if you have here 45 degrees, that means that this is equal to this. So that means that your x and your y coordinate will be the same. And remember that your hypotenuse is still 1 because we are in a trigonometric circle. So if you use your rule, x squared plus y squared is equal to 1, but we know that x and y are equal, we could write this. X squared plus x squared is equal to 1, which means that 2x squared is equal to 1. X squared is equal to 1/2, and then we square root on both sides. So x is equal to 1 over square root of 2. Now, if you remember in chapter 1, when we had the square root at the bottom, we need to get rid of it. So we need to multiply by square root of 2 over square root of 2. So we call that rationalize. So x would be equal to square root of 2 over 2. And y, because y is exactly the same as x, is also going to be that. So you can come back in your circle here and say that the coordinate here is square root of 2 over 2, square root of 2 over 2. And that's for the point that's at 45 degrees. Now 45 degrees, if you remember your circle, 45 is here in the middle. There's how many 45 in your pi? This is pi, so there's 4 of them, so this is pi over 4. So you could say that the point at pi over 4 is equal to this. So if I was asking you to find what is cosine of pi, if I was asking you cosine of pi over 4, what do you have to do? So cosine was always the first value in our coordinate. So that means that here cosine of pi over 4 is square root of 2 over 2. Sine would be the second coordinate, so also square root of 2 over 2. If I was asking you about tangent, tangent is sine over cosine. So that's sine over cosine, sorry. And so if you remember how to divide fraction, you have to multiply by the reciprocal. So it's like square root of 2 over 2 times 2 over square root of 2, and they will just cancel out, so our answer will be equal to 1. So that's if they ask you for tangent. The last point that we're going to look at that's interesting is when the angle is 60 degrees. So if that's 60 degrees here, that means, because it's a right angle, that means that the top angle is 30 degrees. And if you remember, 30 degrees, opposite side is always 1/2 of the hypotenuse, that's 1. So that means that we know that our x value is 1/2. And so you could start again, if you want, using x squared plus y squared is equal to 1. But we already did that earlier, if you remember. We already did that with the 30 degrees, so it's going to come back to the same thing. Your y is going to be equal to square root of 3 over 2. So for this one, you can go back in your coordinate, and you can change, the point will be 1/2 square root of 3 over 2. And if you want to know 60 degrees, think about this is pi. 60 degrees here, so there's one here, one here, and one here. So this is the same as pi over 3. So you could say that the point at pi over 3 is equal to this. If I was asking you, for example, for sine of pi over 3, then you would go in your coordinate and you would take the second coordinate, that's square root of 3 over 2. If I was asking you for cosine of pi over 3, cosine is the first coordinate, so that's 1/2. I could also ask you for tangent. If I was asking you for tangent of pi over 3, then you would do sine divide by cosine. And remember that when we divide, we multiply by the reciprocal. So the answer would be square root of 3. Now, just to visualize a bit better, I could ask you on this circle, you can use your sheet if you want. I could ask you to show me the different places of pi over 2. So if you remember, we start here at 0, and this is pi. So if I want to show pi over 2, it's half of pi. So pi over 2 would be here. And so this one here would be 2 pi over 2. But 2 pi over 2 is the same as pi. And if I keep going, then this would be 3 pi over 2. And here would be 4 pi over 2, which is the same as 2 pi. Now, if I wanted to go backward, because remember when you're going counterclockwise, that's positive. So I'm going to use, if I want to go negative, I'm going to go clockwise. So if I'm going down, then this point here, which was 3 pi over 2 in the positive, is also the same as negative pi over 2. And if I keep going that way, then that would be minus 2 pi over 2. If I keep going, minus 3 pi over 2, and so on. Now with the pi over 3, if you look at this is again pi. So if imagine you separate that in 3 equal parts, so it's going to look like this approximately. So remember, we start at 0, we go positive that way. So that's pi over 3 here. This would be 2 pi over 3 and 3 pi over 3. If you keep going, then you would have here 4 pi over 3, 5 pi over 3, and finally here 6 pi over 3, which is the same as 2 pi. Now if you want to go in the negative, then here you're going to be at minus pi over 3. Here you're going to be at minus 2 pi over 3, and so on, going that way. Pi over 6. Let's look at pi over 6. So remember that this here is pi. So imagine you cut it in 6 equal parts. You're going to have 3 here and 3 here. So this here would be pi over 6. Pi over 6. Then the next one here is 2 pi over 6, which is the same as pi over 3 when you simplify. The other one would be 3 pi over 6, which is the same as pi over 2 when you simplify. This would be 4 pi over 6, which is the same as 2 pi over 3, and 5 pi over 6, 6 pi over 6, and you could keep going 7, 8, 9, 10, 11, 12, until here where it says 12 pi over 6 or 2 pi. If you want to go negative, then you would go that way. So here, the first one here would be minus pi over 6. The next one here would be minus 2 pi over 6 or minus pi over 3. Okay, and so on. And the last one is pi over 4. So this, remember, this is pi. So pi over 4, you cut it in 4 equal parts. You can keep going down. So this here would be pi over 4. The next one, 2 pi over 4, which is the same as pi over 2. 3 pi over 4, and 4 pi over 4. You can keep going 5, 6, 7, 8. At the full turn, it would be 8 pi over 4, which is the same as 2 pi. If you go in red, we're going to go in the negative. So down here, you would have minus pi over 4. The next one would be here minus 2 pi over 4, which is the same as minus 1 pi over 2. So at the bottom, I ask you a few questions. So if you have to find what is the point at 5 pi over 4, so you have to use the right circle. So imagine your circle is here. Okay, I'm just showing you. Pi over 4 are here, right? So 1, 2, 3, 4, 5. 5 pi over 4 is over here. So if you remember the coordinate at pi over 4, it was square root of 2 over 2, square root of 2 over 2. But what I'm looking for is down here. So the coordinate would be negative and negative. So my answer will be negative square root of 2 over 2, negative square root of 2 over 2. Sorry, I just respaced the whole thing so you would see better. So for the second point, they're asking for negative pi over 3. So imagine that pi over 3 are here. Negative pi over 3, you're going that way, so it's around here. You know the coordinate on the top. If you remember, it was 1/2 square root of 3 over 2. Now I'm looking at the one down here. So it has the same x, but it's going to be a negative value. So my answer is going to be 1/2 negative square root of 3 over 2. So the answer of this one would be here. For the next one, they want you to find minus 5 pi over 3. So imagine your circle. Pi over 3 are here. Pi over 3, 2 pi. Oh, sorry, we're doing negative. So let's go that way. So pi over 3, 1, 2, 3, 4, 5. So negative 5 pi over 3 is up here. And we just talked about the coordinate in the previous question. So the coordinate for 5 pi over 3 is 1/2 square root of 3 over 2. And the last one, 13 pi over 2. So you're here, you count by pi over 2, so that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the same as 12 pi over 2. And then 13 pi over 2 is going to be the one on the top here. So what is the coordinate here? It's 0, 1. Have fun!